Hello everyone, my name is Mattia Cafisi and today I would like to present you my Capstone project, which is about creating a Streamlit app that allows users to interact with an algorithm that uses biomarkers as predictors for detecting pancreatic cancer. I selected a topic where development of prediction algorithms is an imminent priority in the medical community, detection of cancer. In particularly, here we are looking at pancreatic ductal adenocarcinoma, which is one of the deadliest cancers, with around 9% of patients surviving over 5 years. Detection of this type of cancer is particularly tough and difficult as asymptomatic in its initial stages, and it is mostly diagnosed late when already in the metastatic or advanced stages. To carry out my project, I retrieved data from Kaggle.com that came from a paper from De Bernardi et al. From 2020, where they collected a sample of 590 subjects, which were classified in healthy, benign, and malign stages of pancreatic cancer. And the data set also displayed biomarkers, urinary proteomic biomarkers levels. I decided to use a singular approach to trying to tackle this problem through a machine learning model that uses multivariate logistic regression as a model. Multivariate logistic regression takes in many outputs, in fact, which are for biomarker predictors, and is capable of classifying them into several outputs, which are in our case the three aforementioned diagnostic stages of cancer. You can see the definition of it on the slide on the left. After performing normality and multicollinearity checks, I decided that neural network was the approach to go with. So you can see in our input layer we have the 4 biomarkers, we have one hidden layer with 4 nodes, and the three output nodes on the output layer. Note that although I'm knowledgeable of the fact that this data set is too small for efficient machine learning based classification using this approach, I still decided to tackle the problem using this direction because I wanted to show a potentially good approach for future larger data sets on pancreatic cancer biomarkers. So what does my app do? It's a sort of a digital playground of neural networks where the user can interact with the future of the model by selecting the number of epochs, the learning rate, the training and testing fraction, and seeing how that changes the accuracy of the model that I developed. As a visual representation of that, I didn't only include the accuracy score of the model, but also a confusion matrix, which allows to see the performance of the algorithm on the testing set. This shows how many subjects for each classifier are classified as true positives and how many are instead classified wrongly. For example, if we look at the last row where we're trying to classify and see how many adenic malign cases were correctly classified, we can see that 36 are malign and correctly classified as such, and 4 are wrongly classified as benign, and 3 as healthy, which are also wrongly classified. On top of the Streamlit app, we can see how the aim is to provide the user with general information about the data, such as the number of subjects present, which is presented in the data set for the 3 diagnostic cases, and they're displayed through a box plot, as well as a simple table showing the mean and standard deviation for each urinary proteomic biomarker level. As we go below, we can see how the user can interact with the testing fraction, selecting it directly, the learning rate, and the number of epochs. You just need to click on the button, train your model, wait for the output, and then you can see the output of the accuracy of our model and the confusion matrix, which shows you exactly how many cases in the testing set were correctly classified. But playing with the model a little bit, I found that it was accurate from 62 to 65% at most, but recently through an improved panel of biomarkers, the same group of researchers was able to detect a pancreatic cancer with up to 80% of accuracy and 2 years prior to the onset of the disease. Those were my references below for the work that I did, and I hope you enjoyed my presentation and the idea for my Streamlit app. Thanks for your attention, and I'll see you guys. Bye.